In this next series of videos, we're going to explore the properties of liquids. We just came from understanding how intermolecular forces play a significant role in physical properties, things like melting point and boiling point. So now we're going to take those ideas and apply them to the liquids. Liquids are a condensed phase of matter, and remember that kinetic energy is proportional to the temperature, as defined by kinetic molecular theory. So we know that all molecules are in constant motion, and we're going to see how this plays out when things like heat are added to a liquid. We're going to look at how intermolecular forces influence what is known as vapor pressure and surface tension. So those are just a few things that we're going to come across in this next series of videos. For right now, I want to just look at the two types of things that can happen when heat is added to a liquid. Let's say we start to apply heat to a liquid. As we add heat, we're going to see the temperature increase. And so that's one thing that will happen. We'll see a temperature change when we're within a single phase. The molecules will be moving faster. We know that according to kinetic molecular theory, that as temperature increases, kinetic energy increases, and molecular motion will increase. As this molecular motion increases and those molecules are moving faster and faster, the attractive forces between the molecules is going to get weaker and weaker, and so that's decreasing, right? If you're moving faster, you're going to have less stickiness with neighboring molecules because you have such higher speed. Another thing that's increasing is what is known as entropy. So entropy is the amount of disorder in a system. And so more movement, more disorder is one way to look at that. The second thing that could happen as we add heat is that we could undergo a phase change. And so we're talking about melting or fusion, if we're going from solid to liquid, or continuing to add heat, we could go from liquid to a gas or have the vaporization phase. The temperature will be constant during a phase change. So ice that is melting is at a constant temperature, the melting point of that ice, which is typically 0 degrees Celsius. Boiling water, 100 degrees Celsius. You cannot heat water under normal conditions hotter than 100 degrees Celsius. So this has an implication when you're in cooking, right? If you want to cook something, it will take longer to cook it in water because we're cooking it at 100 degrees Celsius. If we change the solvent or our cooking fluid to oil, oil has a higher boiling point. And so we can achieve higher temperatures with that oil and therefore cook food faster. So thinking about phase changes again, while the temperature is constant, we are still adding heat. So overall, the energy is increasing, right? And if we're talking about temperature being constant, then kinetic energy is constant. So we're putting in energy in the form of heat, but the kinetic energy is remaining constant. The molecular attractions are still decreasing, right? We have this transition from the liquid to the gas. So think about the differences there. The liquids are closely packed to one another, and gases, those molecules are far apart with very little interactions. And then the amount of disorder, again, is increasing as we go from a solid to a liquid or a liquid to a gas. In the next series of videos, we'll look at quantifying this amount of heat involved in warming different phases of matter and then looking at phase transitions as well. Thanks for watching.